Okay, so we're going to go ahead and find the area. Number 3 says the lengths of the side of a triangular plot of land, so there's my triangular plot of land, are 120, 150, and 175 feet. We want to find the largest angle of the triangle and then find the area of the land. So what this problem is doing is it's setting you up to find the area. Remember our area formula from 9-5 was 1/2 side times the sine of the included angle. So that was the angle that was in between those two sides. So since we have this side case here, what's happening is we have to find an included angle. Now, side is telling us that we should always find the largest angle, which is across from the largest side, which is why the problem is asking you to find the largest angle of the triangle. It's trying to help you out there. So what I'm going to do is set up my largest side of 175, put that in my formula squared, equals the 120 squared plus 150 squared minus 2 times 120 times 150 times the cosine of that angle. So let's go ahead and call that angle, we'll call that x, why not? So now we've got to solve for that angle. Okay, so in your calculator you should take 175 squared minus 120 squared minus 150 squared, and you should get negative 6275. Okay, and that's all equal to the negative 2 times 120 times 150 times the cosine of x. I don't expect you to write this down. I want you to leave it in your calculator. Now we're going to divide by parentheses negative 2 times 120 times 150. And now we have 0.1743, etc. That's equal to cosine. So in your calculator, you're going to do inverse cosine of the answer. So second cosine, second negative sine. And that's going to give us that our angle is 79.96. Okay, so we're going to go ahead and round that to the nearest tenth, which rounds up to the nearest whole number of 80 degrees. So now, when I want to find what my area is, I can use my side, and my included angle. So I'm not going to be using my 175 when I'm trying to find my area. So the area equals 1/2, side is 120, my other side is 150, and then don't forget sine of my angle of 80 degrees. So you should be able to type that straight into your calculator. We're talking about feet. It's not asking us to do any conversions, so we're going to have our final answer is 8,863.3 feet. Area means squared. Now the last problem on here, number 4, it's actually not a law of cosines problem. It's not a law of sines problem. It's just a regular SOHCAHTOA problem. And the reason why we're bringing this up is because tomorrow in class, when you do this worksheet, you're going to have a lot of word problems. We want to get our mind back in the word problem zone, and they're going to be word problems that are any kind of trig, SOHCAHTOA, law of sines, and law of cosine. So we're trying to bring that all together. So this number 4 says you're using a 10-foot 2x12 board to make a ramp for your skateboard. The angle of elevation to the top of the ramp is 10.6 degrees. How high is the end of the ramp off the ground? So this 2x12 board, that's like a 2x4. You know what a 2x4 is? Something that you build things with. So a 2x12 board is just a piece of wood that's 2 inches thick and 12 inches wide, and then the 10 feet, that's the length of it. So the 2x12 is really irrelevant information in our problem. What we need is the fact that the 10-foot board is the ramp. So this is my ramp. That's 10 feet. The angle of elevation. So angle of elevation goes from the ground up. So this angle of elevation right here, that's the 10.6 degrees. And what we're looking for is how tall, how high the ramp is off the ground. So that's going to be this right there. So you can see, we've got to think that this is a right angle because the ground is flat, perpendicular with the height of the ramp. And all we're going to do is we have to remember, okay, SOHCAHTOA, if this is my angle, this is going to be my opposite side, this is going to be my hypotenuse. That means sine is the lucky winner here. It's always sine, cosine, tangent of our angle. We're given our angle of 10.6. So sine of 10.6 equals opposite over hypotenuse. And then you're just going to cross multiply that, type that into your calculator, and you should get that the ramp end is 1.8 feet above the ground. That's it, guys. Don't forget to go ahead and do your give it a try.